Hello and welcome to CS264 Software Design. I'm John Keating. This is week 6 and this is the second part of lecture 11. I gave the lecture this morning in class, but I didn't get through all of the slides because I spent a bit of time talking about the assignment. So I thought I'll finish the slides and record this and put it online for you as well. It's important that you have the material, and the regular lessons associated with lecture 12 will follow. They'll be a little bit shorter, so you don't have to have any more than about 2 hours of class material per week as intended. Okay, let's go straight through to the slide that we were with this morning. And this is the slide we finished with. We were looking at this really interesting class diagram. And we talked a little bit about the various aspects of this, like dependencies, associations, aggregations, compositions. And we went through these in detail, and we talked about generalization, the inheritance. Usually, it's a good idea to inherit from an abstract class. And we can see the difference between the concrete class here, like circle, and an abstract class like shape. In UML terms, is that the name is italicized. That's the only difference here, really. We can see what the attributes are here, and they have a plus or a minus in front of them, determining divisibility, and we have operations, which essentially become methods. We also talked a little bit about here this morning about boundary classes, and here's a boundary class, okay, and a control class, and this was the control class. And you can review this, but in the earlier lesson or lecture actually. So let's move on. So an entity class then, that's a class that represents system objects, and they are kind of the business objects of your application or the model, okay? And again, they're just another one in addition to your control and boundary. There's an example of an entity control boundary, ECB, okay? That's this example here, okay? And really, it's similar to the model view controller pattern that you would have seen in user interface design when we looked at web development last year. So MVC is usually used for user interfaces. ECB is a general pattern for structuring backends. And that's something we may come across a little bit later when we look at patterns. Okay, boundary. The boundary here, this boundary class here, is the REST API. And control, the control class, encapsulates the logic of the design, and entity is the model. So we can see here the control telling us the kind of class we have. Here's a control, here's an entity, here's an entity, here's an entity, boundary, boundary, control, entity, 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 entity. So the entity class, that's the system's objects, it's the business objects, as you can see here. The boundary then is the REST API, that sits and tells us what we want to be able to do. You see there's boundary here. And again, the control is the logic, And so I did talk a little bit about this morning, how this represents an application, how it might look like if you were building your own app for your assignment. Here we can see that shape is an abstract class. It's shown in italics, and shape is a superclass. Circle, rectangle, and polygon here, they're all derived from shape. So it's a generalization here, and a circle is a shape. So a circle is a shape. So it has this inheritance relationship. Shape is part of a window. Okay, shape is part of a window, so it's in part in terms of, and its part representation is aggregation. Okay, it's an aggregation relationship, so it tells us that shapes can exist without the window. So in your application, I think for your assignments, you might want to think about, we're interested in shapes on a canvas. We can create the shape and then we can add them to the canvas. The fact that we can do that means that they can exist independently of the actual canvas itself. So that, again, that's a part of. Point here is part of a circle as well, but it's a composition relationship rather than an aggregation relationship here. So in other words, the points don't exist without a circle. And we had a brief discussion this morning where we talked about, existence and relationships in a philosophical or mathematical sense and so forth. Points, all points exist, or do they only exist when you name them or when you decide that they're there? But we're not interested in the philosophy around this. We're interested in what the design tells us. Okay, so we're not trying to create or model all reality. We're trying to create a model of the application, and that's very often the difference. So this model models the application and should tell us how the application behaves and how it exists and how it's structured and so forth and how we interact with it. Okay, so that's an important aspect. So window here is it's an entity window as well, and it's dependent on an event. Okay, the event is not dependent on the window, so it's a dependency. So we think in terms of like having our events for our applications might be our user interface, that generates the events, to add something to the window. So the window can exist, and what gets added depends on the event. Okay, and then that utilizes, and the logic will tell us it utilizes we add a shape and the kinds of shape. We see, of course, that the attributes of circle are radius and center. Okay, and so it's an entity class as well. And the method names of circle are area, circumference, set center, and set radius. These are the operations, okay? And they essentially become the methods. So the attributes and the methods names of rectangle and the other classes here, they're hidden, okay? So we don't see them, but you would have those as well, okay? The diagram doesn't contain any role information, okay? So we don't know. We don't have window contains shape here. We could see sometimes we would add a role along this line here. Okay, it's above the aggregation line. So, and that role provides directional purposes of association. So it's useful to have those. You might want to look at those yourself and add them. And if you go and, as I said, consult this reference, the visual paradigm help, what's the class diagram? Lots of information there about role and navigation. And in terms of navigability, we can see that the arrows indicate whether, given one instance participating in a relationship, it's possible to determine the instances of the other classes that are related to it. So that's a very useful thing to be able to see and know. In object-oriented design, there's this notion of visibility for the attributes. I mentioned it earlier in this small lecture. These are the data members, or operations, which are method members, and UML identifies 4 kinds of visibility. And you'll have seen these already from your C# programming and your Java programming. Public, protected, private, and package. So we use the plus, minus, hash, and tilde symbols before an attribute and operation name to denote the visibility of the attribute and the operation. Okay, so of course, public is plus, protected is minus, private is hash, and package is the tilde. So the diagram can also see, you can see these plus and minuses here, all right, and we're not seeing any of the package here, visibility at all, nor the protected. Okay, so the diagram shows the multiplicity, and we can see the multiplicity. One window can have many shapes. This is tiny to see this, but it's a star. Okay, and again, this diagram, you can have a look at it online by checking out the visual paradigm what's a class diagram link. You just click through here and it'll take you to that link. So we can see how many objects of the class take part in the various relationships. So 1, 0 to 1, 0 to many, 1 to many, or 6, whatever. There are different kinds of aggregation types. So you can have a look at that yourself. So this was a class diagram. Okay, this is a class diagram. We also can have an object diagram. And an object diagram is a graph, a chart or something that looks like this, that shows the instances, including the objects and the data values. So a lot of time we can see the values. Okay, so we have a class diagram. Here, user has an attachment, and we have this association. We have one or more, zero or many attachments associated with the user. And here we have some information around the object. So we have, here's the object, is U1 is the object, and it has a class user. A1 has a class attachment, and A2 has a class attachment. And we can see that this user, Peter, with this ID, S001, we're following from here, they have a couple of attachments associated with it. Okay, and that's perfectly fine because we can have 0 or many attachments. So the object diagram is an instance of the class diagram, and it shows the snapshot of the detailed state of a system at a point in time. The class diagram represents the abstract model that consists of the classes and the relationships. Okay, but the object diagram represents the instance at a particular moment, and it's concrete in nature. So they have limited use, mostly just to show examples of data structures more than anything else. But they do exist, and it's one of the notations one of the diagrams that are part of the 13 that are provided by the UML. The class diagram here, as we said, represents 2 users in the class and the attachment. A user can upload multiple attachments, so 2 classes are connected in association with 0 to star as multiplicity on the attachment side. And the object diagram shows what the object instances of user and attachment actually look like. At the moment, Peter is trying to upload 2 attachments. So there, it's the sort of thing that could happen in Teams, for example. Okay, so there are 2 instance specifications for the 2 attachment objects to be uploaded. And I guess the reason I'm doing this, I'm laboring this, is that I want you to be able to look at the diagram here and understand the diagram. And the way to understand the diagram is to describe what it is and the associations. So this piece of text on the left here, this class diagram example represents 2 classes, user and attachment. User can upload multiple attachments, so the 2 classes are connected with an association, a line. You might think about whether we have an arrow on this line required based on the discussion we had earlier in the lecture this morning. And then we have the multiplicity as a 0 and star on the attachment side. So really, you need to be able to read this and be able to get this from it. And similarly for the object diagram. Let's move on to a different and dynamic diagram or representation. The dynamism are they in your program. Up until now, we've been looked at the static structure. The class diagram is all about the static nature of the system components. It doesn't tell us anything about how the classes and objects behave. So we're more interested in behavior now when we're deployed. So we use sequence diagrams to do this. Okay, and they're interaction diagrams that detail how the operations are carried out, and they capture the interaction between the objects in the context of some collaboration. So here we have a window UI, we have a chain, which is these are objects. Okay, we can see, and we have a lifeline here of the objects, and we have a window which is of class a window object of class UI, and a chain object which is from class hotel chain, and a hotel which is of class hotel. So these are 3 objects. Okay. And they interact with each other as part of a collaboration and communication between these objects. So they're interaction diagrams that detail how the operations are carried out. So they capture actually the interaction between the objects in the context of the collaboration. And really what's happening is we take these from use case diagrams originally. So these don't come from nowhere, they come from somewhere. So we have a lifeline that comes down here of the object. It starts and activates and it stops. And then we have a message, which essentially we're calling a method, okay? And this object calls a method, this calls a method, and this one, and then we have an iterative loop here that allows us to be able to maybe use some additional objects that are not part of the original lifeline here. So it's interesting, and we can read these, okay? We can read these, and ultimately we can see how this becomes logic in our code. Okay. So they're time focused to show the order of the interaction visually by representing a vertical axis on the diagram for time and showing the messages that are sent and when. And we talk about sending messages, we're referring to calling methods. Okay, and you can check the visual paradigm link here on what's a sequence diagram, or you can check your favorite UML book. Okay. So the sequence diagram is an interaction diagram that tells how the operations are carried out, what messages are sent and when, and the objects involved in the operation are listed from left to right according to when they take part in the message sequence. So remember, as I said, these are objects of these individual, and the class is shown as well. So we can see how the interaction programs are dynamic to describe how objects collaborate. And we see a little bit of that later again. Okay. So designing with UML, are you? Okay, so are you really designing with UML? So I know in class this morning I asked that question about how many of you have seen UML before, and are you actually using it? Or is it just something you have studied and forget about? Okay, so my teaching and learning experiences in computer science and software engineering and their student projects mostly lead me to believe that many students do not always appreciate the value of modeling, design, and UML. I did talk a little bit about this earlier as well. That sometimes they feel that the design is there because it's required, but doesn't actually there's no connection between that design and their requirements, and then there's no connection between the design and the actual code. So I often say if we reverse engineered the code, how would it meet with the design that we actually have in place? Would it be the same design, or is it just something that evolved over time and you really didn't care about the original design? So we don't want that. And again, as I mentioned earlier, this is why for your program and your applications and assignments, I really want you to think about creating a design maybe doing it on paper first, and then implementing your software, and then generating the design, the class design from your code, directly from your code. And I'll show you how to do that in the lessons that follow. And you can look and say, well, yeah, did I actually follow the design, or did I just go off on some tangent and build something that like seemed to work? Okay. So the diagram that a company reports as some kind of summary artifact that's generated afterwards. So that, and they're replicated in the developed code. You want to see this. There's often this disconnect, as I said, between the methodology, say it's Scrum, and the actual design in UML. And often going the other way around, the developed code bears no semblance to the static or dynamic design. So we're going to be looking at design patterns, and I will want you to implement some design patterns in your code, in your designs, and ultimately represent those as code. And then I want you to be able to generate the class structure directly from your code and compare it with the pattern to see whether you did actually meet and implement the pattern. Okay, it's a good learning exercise. So the UML models need to be meaningful. This is really important. They have to be meaningful. You need to understand why you need them and then actually use them in your development. So in large projects, you may get a design and be expected to realize it in code. In small projects, you just have the opportunity to use all the models and learn about them and get them practice for later. Imagine if electronic engineers or car designers or house builders worked without plans and designs. Crazy, crazy situation. So please take time to read and figure out how you might design and test the design specified in UML. It's important. So if you want to get started with UML, I'm going to show you in the little lessons that follow. I'm going to show you some methods and tools. So you may have used some, and I know you used a package already for your software engineering modules, and you have learned or maybe learning about design methodologies and processes, for example, waterfall, feature-driven, agile, Scrum, extreme projecting, or lean, all of that stuff. And UML may be used in conjunction with any of the processes or any other process, or processes yet to be invented. So typically in large-scale projects, UML tools are used to create the designs. You may find the tools tend to be aligned with specific development methodologies, So, and furthermore, tools tend to be designed in a way to support large projects. Many are costly, lots of free stuff, and lots of operating system-specific tools available. Okay, as I mentioned, I use Visual Paradigm. Because it's there's a free version of this for 30 days, and it's not terribly expensive, and it's good for trying it out, and you can always write to the company and tell them you're a student and see what offer you can get from that if you want to work this way. So you can use this link here. I've given the link as a starting point to how you might search for tools. I'm not naming any apart from the fact that I actually use Visual Paradigm. There's actually an online version of Visual Paradigm as well, which is really worth using. And again, as I said, it is a community edition that's supported, and it works for all my requirements. It runs on Mac OS, it runs on Windows, and it's a modeling tool. It's not a drawing tool. Okay? None of these are drawing tools. Okay? They're modeling tools. So you need to focus on the model rather than having them looking like nice diagrams and so forth. So I use Plant2UML as well for modeling and drawing UML diagrams, and you can design with UML using the Windows version of Visual Studio. I can't do this on Mac OS because it doesn't have that for my version of Visual Studio, but there's lots of ways you can work with this. You can go from code to Plant2UML, of course, as well, and I'll show you how to do that a little bit later. So in terms of UML and C# then, just to make that connection, it's straightforward to manually generate code in C# from simple UML diagrams. As the diagrams become more complex, it actually becomes a bit more difficult to generate code, of course. This is why we use something like Visual Paradigm or Star UML to design models and then automatically generate the code from them. So I'm using manual examples given an approach in James W. Cooper's 2002 book on C# and C# design patterns tutorial. And the reason I chose this particular book is I want to let you know that, C# and .NET, it actually has been around a long, long time. Okay, long time. Okay, and UML has been around a long time. They're both old. They're both great. They both work. They're still useful today. Now, these particular, I'm not a great fan of the internal structure of this particular example, but I use it. Okay, I use it because it's in the book, and I tend to use Microsoft stuff as well, Microsoft examples and more modern examples. But yeah, this works pretty well. So there's a public class person. Here's a person, has two hidden elements here, and we have the constructor and we have the methods. It could just look like this if you wanted to have it like this, but this is a better representation class-wise. And this then is the code that corresponds to this. And with a little bit of time, an effort, you will be able to use these and then generate a class. It's instructions. It's fairly straightforward. You have to make that connection. And in fact, it's possible to go the other way from this code to this diagram as well. So, but we have tools that will allow you to automate that, so you don't have to do all this stuff manually. Okay? So for example, here is an inheritance diagram generalization. Again, I'm just copying and using the example from James W. Cooper's book on design patterns. I didn't write these or design, it's his diagram, so I'm using it here. But again, here we have this abstract class person, and then we have some of the attributes, and here we have the constructor, here we have the methods that we expect, and now we have public class employee, which inherits from person, generalization, and then this is what we would expect here. And we have to override abstract methods. So for example, if it's an abstract class, it's an abstract class that's declared abstract, or if it contains an abstract method. And then if it contains an abstract method, you must declare it as being abstract. The same thing works for Java. And then when you have your concrete class, which is the generalized subclass, then you actually have to implement the abstract method. Okay, and here in C# we actually say public override. That tells us we're overriding this earlier abstract one. So there's this connection here in terms of generalization between the UML and the C# code. Again, it's fairly straightforward to be able to do this. Here, example, is a plant UML class diagram that, and here we have a class, and that's why we have the C, it's a class. We may have abstract classes as well, may have different notation for this. It has a main method in here, and has two methods, concat and sum, and it's useful. So I know I may have actually appeared dismissive about this earlier, like in terms of UML model generation from your code, but hopefully I did say that, it can have a very useful function. It's a very useful function in terms of an integrity check to see, am I actually realizing the patterns? Are my designs on track? Do I really understand what's happening in terms of design here? I will give the example demo in the shorter lessons that follow here, okay? When you want to generate a model from your code base, you can actually do this using VS Code and some plant UML extensions, and I'll show you how to do that in the lesson, and we can see that using the demo a little bit later. But this is a perfectly acceptable class diagram. These are kind of things that we'll be asking you to provide as part of your assignment. Okay, so that's really the final part of this, and we learned about implementing C# class hierarchies using UML at the end. And we also learned about UML descriptions for software design patterns, and it's important that you understand this for later, okay, because you will need this. Thank you very much for watching, and for it's a lecture 11, not a lecture 9, but yeah, and I'll see you in lecture 12. Thank you very much.